Welcome back to Algebra 2. Today we are doing 6.7 modeling with quadratic functions. Now don't flip out about the word modeling because we know that usually means that we're working with real-world application and word problems. But remember that when you do something in mathematics, generally your boss isn't going to tell you to go sit down and solve equations all day long. He's going to give you a scenario that you're going to have to figure out. So anybody who's taking physics, this is going to look a little bit familiar because we're going to talk a lot about projectiles and things being fired or being dropped that follow the path of a parabola. So exercise 1. An object is fired upward with an initial velocity of 112 feet per second. Its height in feet above the ground as a function of time in seconds since it was fired is given by. So blah, 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 blah. Basically, this is what we're talking about right here. Here's our equation. All right, at what height is the object fired? So what you need to do here is determine what are they asking you to find. So in this case, at what height is the object being fired? I always go back to think to myself, well, I know that if I have, oh, crumb buns, I opened the wrong one. This one, I'm sorry. So if I have a negative leading coefficient, I know this is going to look something like this, all right? Now, if by chance it is being fired from the ground, the height will be 0, but I don't know where that is. So I need to find out what the y-intercept is. And if you look at it, because we don't have a constant here, so what I'm looking for is the y-intercept where x is equal to 0. So if I take my example and I find h of 0, it's equal to negative 16 times 0 squared plus 112 times 0, right? So h of 0 is equal to 0. So this one is actually going to look like this. It's going to start at 0 and go up and down. So something like that. All right, now B says sketch a general curve of the equation, which I just kind of did. So what this would look like is something like this. Because t is time, we're going to be a first quadrant quadratic, so it's going to look something like this. I always try to visualize it in my head. It'll make things a little bit easier. All right, so moving on to C. Algebraically, find the time that the rocket reaches its greatest height and the maximum height. Label these on the graph that you drew in part B. So what we're looking for here, again, go back to your picture here. So h. So what I'm looking for is my y that's associated with my x, all right, or my h of t, not my t. So algebraically find the time the rocket reaches. So I'm looking for the vertex. Now, do they tell us we have to do this algebraically? It does. But also, guys, you can put this in your calculator, find out what the vertex is, and make sure that what you're doing is right. All right? So now algebraically, actually, you have to determine what the x and the y are of the vertex. So how do you find the vertex algebraically? Well, you could use vertex form and complete the square, or you can realize that that x that's here also represents our axis of symmetry. And if you remember, the formula for the axis of symmetry is x equals the opposite of b over 2a. So the opposite of b is negative 16? No, 112. So negative 112 over, I don't just look here. Yes, negative 112 over 2 times negative 16. Put that into your calculator and you get 3.5 seconds. So that's my x, right? Now that doesn't give me my greatest height. It's just giving me the 3.5. So now what I have to do is take that 3.5 and do h of 3.5, which is negative 16 times 3.5 squared plus 112 times 3.5. Put that whole thing into your calculator and you get 196 feet. So that's my highest point. And again, I would always take a second or a moment and put it back in my calculator and make sure that the vertex in my graph is 3.5, 196. So make sure you're answering the right question. Label these in the graph that you drew on part B. So basically what we're saying is this is 196 up here, and this is 3.5 down here. Algebraically determine the time when the rocket reaches the ground. Well, what are we looking for here? We're looking for this point right here. It's the larger of the two zeros. And again, you can do that part in your calculator, but they're asking us to do it algebraically. So again, if we're looking for the x-intercept, that means that y is equal to 0. So we're going to get 0 equals negative 16t squared plus 112. Right? How would you solve this? I'd probably factor out a negative 16. There's a t there, I'm sorry. Negative 16t and get t minus 7 equals 0. Again, you can put the equals 0. You know me, I don't like it here. So I would rather put my equal 0 on this side. So I get negative 16t is equal to 0, so t equals 0. Or I get t minus 7 equals to 0. So t equals positive 7. So there are our t is 0 and t is 7. But remember, they're asking for when it hits the ground. So the answer for this one is going to be t, so 7 seconds. I actually shouldn't put boxes around them. I should definitely put a box around this one because this is the answer to the question. Okay? Again, please, let's make sure you're listening and paying attention to what I'm doing, and then pause it and write things down. All right, moving on to exercise 2, a skateboard half pipe. And I guess that because I don't really know skateboarding, I figured something like with the snowboarding half pipe that I love to watch on the Olympics. So a skateboard half pipe ramp has a shape in the form of a parabola whose equation is, and you know me, I like to always put boxes around my math, where x represents the horizontal distance across the 20-foot wide half pipe, and y represents the ramp's height above the ground in feet. With the help of your calculator, sketch the graph of the half pipe below. Calculate its height of the endpoints at the endpoints and the minimum point. All right, so the half pipe looks something like this, right? They give us the equation. So when you put this into your calculator, again, I know you don't have a calculator with you, but we're only talking about the first quadrant. It hits this point at 7. It hits this point at 10, 1, and it hits this point at 20, 7, because it says it's 20 feet. So we're only looking at between 0 and 20. So that's all we had to do in that one. I could have actually moved that all the way over here, but I don't think, yeah, it won't let me move. So that can be in the middle. So that's all they wanted you to do for that one, just to get an idea of being able to visualize what the equation looks like and what the scenario is that they are setting up for you. So let's move on to exercise 2 when you're ready, of course. Exercise 3, that's what I meant. Remembering that the popcorn factory has determined that the percentage of kernels that pop rises and falls as the temperature of the oil and kernels are cooked as, gosh, I can't even read today. Let's try this again. Remembering that the popcorn factory has determined that the percentage of kernels that pop rises and then falls as the temperature of the oil the kernels are cooked in increases. It modeled this trend using this equation. All right. So where P represents the percentage of kernels that pop and T represents the temperature of the oil in degrees. So that's kind of important. P is the percent of kernels, T is the temperature of the oils. So algebraically, determine the temperature at which the highest percentage of kernels pop. Also determine the percentage of kernels that pop at this temperature. So they're looking for a point. So what point are they looking for? Determine the temperature at which the highest percentage of kernels pop. So think about what this looks like, right? Because it's telling me to sketch the curve. So let's do a little bit of sketching the curve. It's the first quadrant. And we know it's going to start somewhere, and then this one isn't going to start at 0. So let's say it looks something like this. I'm going to just slide this up so I have a little more room. So what they're looking for is this point right here, which we know is the vertex. So what we know is this number, and we need to know this number. So how are we going to do this? We're looking for the vertex. So again, you can do it by completing the square, but you're going to get kind of an ugly looking thing with these numbers. So I'm going to use that same formula for x equals negative b over 2a, which is equal to negative b, which is negative 2.8, divided by 2 times negative 1 over 250. Remember, you have a calculator. Don't flip out by the fractions. So this actually comes out to be 350 degrees. After you put that whole nastiness in your calculator. So your degrees is going to be this number here. So this is your 350. And what we also need to know is what the y is right here. So we know that p is equal to negative 1 over 250 times 350 squared plus 2.8 times 350 minus 394. And you put this whole thing into your calculator, carefully of course, and you come up with 96. And remember, this is the percent, so it's 96%. So this number up here is 96. Now, it says using your calculator to sketch the curve, which we did, label your window, and I guess we can also take a look at what my zeros are, because in C it says using the 0 command on your calculator, determine to the nearest degree two temperatures at which P equals 0. So they're not telling us to do this algebraically, which is kind of nice. So we can go to our calculator and we can say, well, we can look for our zeros here and here using the 0 function. If you don't remember how to do that, please ask me how to do it in class. All right, I'm not going to spend time doing it here on the video, but this comes up to 195 and 505. Because I guess anything above 505, then more than probably things start to burn. All right, label them on the graph, which I did. And D says, if a typical batch of popcorn consists of 800 kernels, how many does the Crazy Caramel Corn Company expect to pop at that optimal temperature? Well, we just figured out that 96%, right? 96% of 800 is going to be what? So 800 times 0.96, because that's optimal, all right? So you get 768. All right, moving on to E. For a batch of popcorn to be successful, the company wants at least 85%. So we did one like this before with 50% of its kernels to pop. Write an inequality whose solution represents all temperatures that would ensure a successful batch. Solve this inequality graphically. All right, so what would this look like? It would be negative 1 over 250, which is this is our example, our equation. And we want it to be greater than or equal to 85%. I don't know where 84 came from. 85%. So we're going to solve this. We're going to bring this over. So minus 85, and it's telling us to use our calculator. We have to do it algebraically, graphically. So what they're telling us to do here is when it's greater than or equal to 85, so you actually don't even have to do this. we can go to our calculator, take a look at our equation. I'm going to go back up here to the graph. So what they're saying is at 85%. So we have to look for 85% here. All right, you're going to come up with two numbers. So again, we can do this. So we're looking for this one and this one. And if you do it properly, this should be 298. I'm going to write it here. 298 is this one, and 402 is this one. I'm going to remind you, you can also do this in your calculator, or you can do it by hand. I don't think ever on the Regents exam they'll ever ask you to use your calculator, but basically if you wanted to write the inequality, it would look like this.
We have one afternoon announcement. All Air Force Junior ROTC cadets who will be attending the recruiting event at the middle school today report directly to JROTC room for instruction. Again, all Air Force Junior ROTC cadets who will be attending the recruiting event at the middle school today report directly to the JROTC room for instruction. Thank you.
Sorry about that. I thought I paused that and you got the whole message there. But we're done. Okay, so at this point, we're going to work on the independent practice together because I don't think doing this alone is very wise. And until next time, always make good choices.